Sometimes when tasked with adding or subtracting rational expressions, we don't have common denominators from the outset. So we have to find what that common denominator is. So in this case, we need to look to see what do both 4 and 7 divide into evenly, as well as what variables need to be present in both denominators. So first of all, with the numbers, hopefully we know that the smallest number that both 4 and 7 divide into is 28. So we're going to have to multiply the first fraction by 7 on the top and bottom. And then for the second fraction, we're going to have to multiply by 4. But we also need to bring an x into that second denominator. The first denominator has an x in it, so the second one needs to end up having an x in it as well. So we have to have complete overlap between the two denominators. So we're going to end up with, overall, in the denominator, 7 times 4x, which is 28x. And then in the two numerators, we've got 7 times 3, which is 21, and then minus, since this is a subtraction problem, 1 times 4x, which is 4x. And so at this point, we might be tempted to reduce the 21 and the 28, for example, or maybe the x's between the 4x and the 28x. But recall our rule still applies when reducing rational expressions. You can't reduce things that are connected by addition or subtraction. So in this case, this 21 minus 4x over 28x is as good as we can do. In the second example, so again, we're looking to make sure the denominators end up the same. So that first fraction, I look at the number, I see a 5. In the second fraction, I need a 3. So the smallest number that both 5 and 3 divide into is 15. So I'm going to need to multiply the first fraction by 3 on the top and bottom, and the second fraction by 5 on the top and bottom. But that's not all. I also need to make sure that the variables match up. So I look in the first denominator, I've got y squared. In the second denominator, I have just y. So I need both of them to have the same number of y's. So I need to multiply by a y on the top and bottom of this second fraction. And then if we look at the z's, the first fraction has a z in it. The second fraction has a z squared. So likewise, z squared is going to be where I'm going to see that overlap. So I need to multiply the first fraction by that extra z. So in the end, we end up with 3z times 2x, so that's 6xz, and then plus over here, we're multiplying 7 times 5y, so we get 35y. So there's our numerator, and then our denominator is going to be 3 times 5, which is 15, and then the y squared and the z squared. And so here again, there's some tempting elements to potentially reduce, but because the numerator is connected by addition there's no reducing that we're going to be able to do. This is the best as we get. Whenever there's any addition or subtraction involved in the denominators, we're almost certainly going to have to do some factoring in order to try to figure out where the overlap is between the denominators and what that common denominator needs to include. So for the first fraction, I'm going to factor that denominator. So x squared plus 2x minus 8 is going to factor into two sets of parentheses with x as the first piece. I can see that I'm multiplying to make a negative 8, so it's got to be one of each. And then I'm looking for two numbers that multiply to make 8 but have a difference of 2. So that's 4 and 2. And the 4 needs to be the positive in order for me to end up with a positive 2x in the middle. So we've got x plus 4 and then x minus 2. In the second fraction, there isn't anything that we can do there, so we'll just leave that as x plus 4. So now we look at these two denominators, and we have to try to determine what will that common denominator include. And so any factors that we have in either of the denominators eventually have to be present in both. So we can see they both have this x plus 4, but the first fraction has an x minus 2 in the denominator. So that means the second fraction needs to have an x minus 2 in it as well. And so we can multiply the top and bottom of that second fraction by x minus 2. So now we'll have the same denominator in both. So we end up with just x plus 4 times x minus 2 on the bottom. And then in the numerator, we've got the 2 coming from here, and then plus, so we have a plus sign there. And then we've got this multiplication that we're going to eventually use the distributive property on. So 3 times x minus 2. And so we do not need to clean up the denominator. We can leave that in this FOILed form. So I'm going to leave this as x plus 4 times x minus 2. But we do need to clean up the numerator. So up top here, I'm not adding the 2 plus 3, but instead I have to, as I mentioned earlier, distribute. So I'm going to have 2 plus, and now it's 3 times x was 3x, and then 3 times the negative 2 gives me a minus 6. And so then our last step is to just gather the like terms that we see in the numerator. Again, denominator is just going to stay as is, so x plus 4 times x minus 2, but then in the numerator, I've got the 3x, and then I've got the 2 minus 6, so that gives me a minus 4, and so this is my simplified answer. For the next example, we have x plus 5 in the first denominator and x minus 3 in the second. And so even though they both have x's in them, these are really just two unique denominators. It'd be the equivalent of having 1 over 5 minus 1 over 6. There's no overlap between those, even though they're both numbers. So I would have to multiply the first fraction here by 6 on the top and the bottom, and the second one by 5 on the top and the bottom, so that I would end up with a common denominator that includes both the 6 and the 5. So that same principle applies on this one here. So I'm going to need to multiply that first fraction by x minus 3 on the top and bottom. And then the second fraction, minus. The second fraction, the 3 over x minus 3, I'm going to need to multiply the top and bottom by x plus 5. So this way, both of my denominators are going to end up with the exact same thing. They're both going to have x minus 3 and x plus 5 in them. So I can go ahead and create that. So x minus 3 times x plus 5 in the bottom. Now in the numerator, I'm going to have some work to do. So I'll leave it in this undistributed format first. So x minus 3 times 4, and then minus 3 times x plus 5. And so the denominator, as it does on all these problems, once we get a common denominator, is just going to stay as is. But then in the numerator is where I still have some work to do. So I'm going to have to distribute this 4. So I get 4x and then minus 12. And then here is where we have a tricky piece. So this is minus 3 times this x plus 5. So I'm going to be distributing a negative 3 to both of those. It's an easy thing to overlook. But on subtraction questions like this one is, we end up distributing a negative in this kind of circumstance. So in the end, we have negative 3 times x gives us negative 3x, and then negative 3 times 5 gives us negative 15. And so now, again, our denominator is going to stay put, x minus 3 and x plus 5. And then in the numerator, we just have to gather our like terms. So we have 4x minus 3x, so that just gives us x. And then minus 12 and minus 15 gives us minus 27 when we combine those. And again, even though the numerator has an x and we see x's in the bottom, there's a 27 and a 3, none of this is reducible because everything is connected by addition or subtraction in the numerator. So we can't reduce it with anything that's in the denominator.